All right, this is the section 4.5 second video. I found one that I had previously made that had problems E and G completed, and so I'm making this video to complete D and F. So remember, when we look at what are we trying to find with these problems, what are we trying to do? We had a list of things, remember, that we wanted to find. So we had that we wanted to know the domain of the problem. We wanted to know if there were vertical asymptotes or holes. We also wanted to know if there were x-intercepts, a y-intercept, and then horizontal or oblique asymptote. Remember, you can only have one of those two types because that has to do with the relationship of the degree of the numerator and the degree of the denominator. So the first step is always going to be factoring kind of what's going on up here. So this factors into an x minus 3 and an x plus 1 because we need to multiply to -3 but add to -2. So before we reduce, because I do see a reducing step here, we want to make sure that we include both values in our domain. So the restricted values here would be a -1 and a +3. Now we can reduce this. This would be a 1 on top because this is going to cancel, but there's still a 1 here, over an x minus 3. So the only one that is a vertical asymptote is +3, since that is still in my denominator. We do have a hole. The hole is found by setting the part that cancels equal to 0, and then plugging that back into the reduced function. So I'm going to plug -1 into this reduced function. And that's going to be 1 over -4 or -1/4. So there's my hole. X-intercepts, there are none in this problem. Even though there was an x in the numerator originally, x-intercepts have to be after the reducing step. There is no longer a factor with an x up there. So we will have no x-intercepts. The y-intercept is found by doing f of 0. So that's 1 over 0 minus 3. That is -1/3. Remember, 0 comma number is how we write y-intercepts. And then when we look at this, you can look at the reduced form if you want to look at for your horizontal versus oblique. The degree of the numerator is 0 because there is no x. The degree of the denominator is 1. When the degree of the top is less than the degree of the bottom, it's going to be a horizontal asymptote, and it is the line y equals 0. And you can see that by doing long division. X minus 3 cannot go into 1 because you can't put something with a bigger x into something with a smaller x or no x. So let's put down what we know. We're going to do our vertical asymptote and our horizontal asymptote. So the vertical asymptote is at +3. And then we're going to do our horizontal asymptote, which is at 0. And then we're going to plot some of the points we know. So I'm going to highlight the points that we do know. This is a hole, so we'll do an open circle, and this is an actual point. So at -1, -1/4, we're going to put that open circle. 0, -1/3, we're going to put a point there. And that's all we have for points that we know so far. So remember, that's never enough, so we need to do a chart. And we use x-intercepts or vertical asymptotes to split up our chart. We really only have a vertical asymptote this time. So at 3, we had a vertical asymptote. So we want to pick points on each side of this. So I'll probably pick 4 and 6 on the right side. Now for the left side, I'm going to be a little strategic. I'm going to pick 2 because that's close to the actual vertical asymptote. And then maybe I'm going to pick something a little further down, maybe -6, just so we can see something a little further down this way. So let's plug these into our function. So 1 over -6 minus 3 is -1/9. 1 over 2 minus 3 is 1 over -1 or -1. 1 over 4 minus 3 is 1 over 1, which is just 1. And 1 over 6 minus 3 is +1/3. So let's plot what we've found. -6, -1/9 is very tiny, right below that line. 2, -1, it's right here. And then we have 4, 1, and 6, 1/3. So all of our points are very, very close to our lines. Remember, when you get to your vertical asymptote, you cannot cross that. Now, what we talked about in class was that sometimes you can cross through the horizontal asymptote, and the little check if we cross the horizontal asymptote is that you set your reduced equation equal to your horizontal asymptote, and you try to solve for x. So if we cross multiply, we get 1 = 0. So no x to solve for means we don't cross. So I know that that hovers on that blue line and does not cross it. Okay, I had E and G on the other video that I already posted, so let's look at F. Same list, we need our domain, we need our vertical asymptotes versus our holes, we need our x-intercept, y-intercept, horizontal asymptote, or oblique. Okay, so factoring the bottom, we'll get x + 4 over, this is a difference of two perfect squares, so it'd be x + 2, x - 2. That means we have two domain restrictions of -2 and 2. Nothing cancels, so those are both vertical asymptotes. And we have no holes. We do have an x-intercept. We have x + 4 is in the numerator, so that would be at -4, 0. The y-intercept, we put in 0, and you can do that in the original if you want, instead of the factored form. Sometimes that's a little quicker. So that's at -1. Okay, horizontal versus oblique. So if we look at the original or the factor form, sometimes the original helps you compare the degrees. It should be the same rule no matter what once we've finished it out. But when it's all foiled back out, you can see the degrees a little bit better. So this has a degree of 1 and this has a degree of 2. Again, when you have a degree that is smaller on top, you get a horizontal asymptote at y = 0. Now that is interesting because that means we are going to cross our horizontal asymptote, because if our horizontal asymptote is the x-axis and we technically have a point here that exists, that means we're going to be crossing through, and I'll be able to show you that when we get to that step and do that check for solving over here. So let's do our vertical asymptotes in red and our horizontal asymptote in blue like we've been doing. So at -2, we have a vertical asymptote. And at +2, and we are looking at a horizontal asymptote at 0, so y = 0. Okay, and then the points that we know are the x-intercept and the y-intercept. So the x-intercept is happening right here on our horizontal asymptote, and this one is down here. Now this is a little different than our previous sections because we actually have two vertical asymptotes. So this is different than the ones we've done before it. And we want to look at multiple things going on here. There's like 3 regions essentially that the vertical asymptote split us into. And we also have this x-intercept. So the x-intercept is the first thing we encounter. So we include both those and vertical asymptotes when we split up our table. We have a vertical asymptote at -2. And we have a vertical asymptote at +2. Oops, try to write that right. So we want to pick some x values in each region. So to the left of -4, maybe I'll pick -6. And I may not need 2 points here because I am going to get another point on this side of the red. But we could do another one if we want, so maybe -8. Between -4 and -2, there's really only -3. And then I'm going to do 2 points in between these two red lines because I want to know what's happening to the left of the y-intercept and to the right of that y-intercept. So maybe I'll do -1 and +1. And then I'm going to pick 2 points to the right of +2. So let's do 4 and 6. So a lot more actual steps to work out this time. And if you want to plug it into the factored form or into the original, either one's okay, as long as you can calculate them in your calculator or calculate them by hand. So if I plug it into the original for -8, it's going to be -4, and that is 64 minus 4 over 60. That reduces to -1, I believe. 60 divisible by 4. I wanted to say it was, yeah, 1 over 15. So this is -1/15, so very small. If we plug in -6, that's going to be a -2 over 36 minus 4 is 32. So that's going to be -1/16. Again, very small. And then if we plug in -3, that's going to be +1 on top. And then that's 9 minus 4, so that's going to be 5. So that's 1/5. Oops, my -1/16. I didn't write over here. And then for -1, that is 3 over 1. Okay, be careful here. This is +1, but -4 is -3. So that's going to be a -1. And then if we plug in +1, that's going to be a 5 over -3, so -5/3. And then we have 4. It's going to be 8 over 16 minus 4 is 12. So that reduces to 2/3. And 6 plus 4 over 6 squared minus 4 is 10 over 36 minus 4 is 32. That would be 5/16. And again, if you struggle with the fractions and knowing where to plot them, you can just do numerator divided by denominator in your calculator and get a decimal approximation for each one of these. So -8, we have -1/15, so it's super tiny. And then -6, we have -1/16. So it looks like this graph was on the bottom half before it got to that crossing point. Because at -3, we're on the positive half, we're at 1/5. So it actually comes up and goes up here. So this line, it crossed at that x-intercept, which we're going to prove that to you and that we knew that that was true in a minute. But because my asymptote and my x-intercept are in the same place, I knew it was going to cross it. But it crossed it and it just kind of hovered below that line forever. And then in the middle, we have -1 is -1. Now that's kind of interesting because that's the same height as our y-intercept. And 1 is -5/3. So what this means is that there's probably an upper little point. If we plugged in -1/2, I bet it would be higher than these two. My guess is this is some kind of wonky little parabola. It looks like it's going down on both sides. But if you needed to see another point to prove that, because it can't go across this red, and it really should not cross the blue because we see that there's really only one x-intercept that we're supposed to have. And then for the other ones, we have 4 is 2/3 and 6 is 5/16. So this looks like it is staying in the upper half. Okay. So then you want to say to yourself, how do I prove or check whether or not the horizontal asymptote should have been crossed, which is what happened, and is it the only place it should have been crossed? Because this little method right here will actually tell you the only locations that it can be crossed. So if we set our function, which I'm just going to use the original since it didn't factor into anything that canceled, equal to our horizontal asymptote, and we go to cross multiplier. Yes, this zeroes out, but we still get x plus 4 on the other side. If we solve that, you notice that this is where we cross. The x value of -4 is where we crossed our asymptote. And it happens to be that the y value is 0 here because it is on the x-intercept list. So, and it's also where our horizontal asymptote is. So anytime you get this x value, the y value coordinate that's going to cross is always where that horizontal asymptote is located, which ours is located at a y value of 0. So this is kind of an interesting one, a little more difficult than something we would give you in class, but it's nice to see some of the pieces come together. So I will fill in the rest of the writing for E and G and post this all together, but the video might look slightly different for those two because it was from a previous semester's notes, but I did have both of those worked out for you. All right, have a good weekend.